I think today's agenda was going to be the core root proposal. Is that right, folks? We're going to walk through that.
Yeah, I think Tanton prepared to talk about Cobalt work with UPL.
Okay.
Yes.
And I know one of the 9 elements had some questions on the email reflector, but if they're not here, we probably don't need to go through that. We can just probably should just stick to our agenda, go through that presentation, and then we can catch any opens or actions on the back of that. Does that sound good, folks?
Yeah.
All right. Start sharing.
Yeah, Tanton, you can go ahead.
Okay. So can you see my screen?
Yes.
Okay. Okay. Hello, everyone. My name is Tan Dun. I'm from Intel. So today I'm gonna give a presentation about the progress and the plan in Cobalt with universal payload. This presentation gonna take around 15 minutes, and it will consist of 3 parts. First of all, I will shortly explain the background information, like the reason of this project and the goal, following with what has been done. In the end, I will explain the next steps. The goal of this project is to boot Cobalt with EDK2 universal payload through universal payload interface. The current situation is that we can already boot Cobalt with EDK2 UEFI payload with CBMEM. However, universal payload can only consume the universal payload interface, which is specified as hub now. It can be Sybil or something else in the future. In order to boot Cobalt with universal payload, the CBMEM in Cobalt needs to be converted to universal payload interface before loading universal payload. Now there are a lot of bootloader and payloads in the world, and they can produce or consume different payload interface. In the future, probably we can use the similar implementation to unify the interface between other bootloader and payloads. So these 2 goals are what we want to achieve. So far, we can already boot Cobalt successfully into Windows OS in QEMU with universal payload. You can find the code in the link here to have some clue about what we did. These changes are all in the Cobalt repo. Then I will introduce the main steps of this POC code. The first step is to generate universal payload in EDK2. As you can see in this image, universal payload consists of universal payload entry module, UEFI-FV, and universal payload info. Firstly, we set the image base of universal payload entry into this address. This can be achieved by LLVM linker and the linker script in EDK2. Why we modify the image base of this payload is due to the Cobalt will not relocate the payload. Then we build 32-bit universal payload entry module by LLVM since we want to align to Cobalt. Finally, we add UEFI-FV and the universal payload info sections into universal payload F file by LLVM obj copy. These steps are integrated in a Python script in UEFI payload package of EDK2. After generated universal payload, the second main step is to convert universal payload to CBFS component in Cobalt image. More specifically, first of all, we add universal payload entry as an ELF payload by make menu config to include universal payload in Cobalt image. Then, the CBFS tool in Cobalt is modified to include extra 2 sections that we added before. After this, the load address is fixed up to ensure all the sections will be loaded to the memory at the runtime. In these slides, you can see the CBFS component format in Cobalt image, which is converted from universal payload. The coupled image consists of many CBFS components. The sections in UEFI payload will be converted to different self-segments in CBFS component. All the modifications mentioned in previous slides are done in build time. The third main step is to convert CBMEM into hop in Cobalt. During the runtime, since the input of universal payload is expected to be a hop list, the CBMEM in Cobalt is converted to many hops, such as the serial info hop, video info hop, SM BIOS hop, and ACPI table hop. Another thing we did is to convert CB memory in Cobalt table to resource hop and the memory allocation hops to pass memory info to payload. Following with build extra data hop to record the load address of UEFI-FV so that payload entry module can find UEFI-FV and load the DXE core from it. With all these main steps we explained above are done, in the end, Cobalt will jump to the entry point of universal payload and passes the address of hop list to universal payload. So these informations are about what we have done in the Cobalt PLC code. As we shown before, what we have done is kind of like demo to show the possibility to boot Cobalt with EDK2 universal payload through universal payload interface. Here we will introduce the idea of adding a shim layer to minimize the changes which need to be done in Cobalt. Basically, the shim layer is between Cobalt and the universal payload, as you can see in this image, and it will be implemented as a module in EDK2. Furthermore, the shim layer binary will be included in CBFS as an ELF payload. We came up with 3 different solutions to fulfill this shim layer idea, and to implement every solution, we have to conduct 3 steps. First of all, we add universal payload in final image at build time. And then the second step is to load universal payload at runtime. In the end, shim layer converts CBMEM to hop and calls universal payload. The differences between these solutions are about how to conduct the first and the second step. For the first solution, Cobalt will include universal payload as a separate binary, as the image shown on the right-hand side. The shim layer decompresses and loads universal payload from a fixed location. In the end, shim layer converts CBMEM to hop and calls universal payload. The advantage is that no change needs to be done in Cobalt. However, shim layer cannot reuse the decompression code in Cobalt. In the second solution, Cobalt includes universal payload as a flat binary type secondary payload. Then shim layer still decompresses and loads universal payload. The difference between solution 1 and solution 2 is the way to include universal payload in the final Cobalt image. The pros of these solutions is that it aligns to the existing secondary payload implementation in Cobalt. The cons are that a new secondary payload needs to be supported by Cobalt, and the shim layer cannot reuse the decompression code in Cobalt. Since I have been working on it, here are the link of my code in EDK2 and the Cobalt fork repo for this solution. In the last solution, Cobalt also includes universal payload as a flat binary type secondary payload, which is same as the solution 2. The difference is that Cobalt decompresses universal payload to this address in RAM stage instead of shim layer. In the end, shim layer calls the universal payload. The benefits are that this solution still aligns to the existing secondary payload implementation in Cobalt, and the decompressed code in Cobalt can be reused. However, the drawbacks are that a new secondary payload should be supported by Cobalt, and Cobalt needs to decompress the secondary payload. And here are the link of my code in EDK2 and the Cobalt fork repo for this solution. So we can put these 3 solutions together and compare these 3 solutions. The similarity and the differences between these three solutions are shown in the table. The light box means the non-coupled change. The dark boxes means the changes in coupled. So you can see in solution 1, no change needs to be done in coupled. On the contrary, the solution 3 contains the most changes in coupled. However, in my opinion, I would prefer the third solutions compared to the solution without shim layer. Solution 3 have minimized a lot of changes to coupled. In the meantime, the third solution aligned to the existing secondary payload implementation in coupled. Adding another secondary payload may not be complex in coupled. Besides, the code to locate the CBFS component and the decompressed code in coupled can be reused. In brief, we want to co-work with coupled and other community instead of doing these things only in EDK2. So I prefer the third solution to boot coupled and universal payload by a shim layer. And I would like to know your opinions about these solutions. So that's it. Thanks. Do you have any questions?
Your preferences make sense, Dun. I agree solution 3 seems best. I think the thing we have to think about is likelihood of upstream acceptance in core boot. My guess is that solution 2 would probably be a little bit more upstream friendly, but then again, I'm not quite sure what the core maintainers might think.
Yeah, the solution 2 only needs to include to support a new secondary payload, and the code compared to the solution 3 will be less. But in solution 3, the code will not be much bigger. The code to decompress payload and to locate the payload can be reused in coupled.
So chain loading payloads is something that the core boot maintainers have been talking about for a fairly long time. As long as solution 3 enables chain loading of not just universal payloads, but traditional core boot payloads, I think you'd be fine with upstream acceptance.
Yeah.
Yeah, but the solution 3, actually we have some hard code interface there. So if we go back to the detail of solution 3, I remember the UPL binary is loaded at the base address, at a fixed base address. And then the shim layer will assume the UPL is at that fixed address. In the slides, the fixed address is 16 meg. Yeah, it's 16 hex. 160. I'm sorry, 160 and plus 40. I think this needs also to be discussed with the co-boot if we want to use the solution 3.
As long as you make it generic such that, the CBFS is able to just decompress, arbitrary payloads, and have it work regardless of whether it's universal or not, there's a pretty good chance that it would be acceptable upstream. But what I've seen from the maintainers thus far is that they don't necessarily have any issue with universal payload, but they don't want RamStage to directly natively support it. They want it to be they want a shim that converts from CBMEM to universal payload format to be distinctly separate from RamStage. In general, there's a feeling that RamStage already does too much.
Yeah, in RAM stage, Cobalt will only decompress and unload the payload. In Cobalt will not to handle any secondary payload, so this might be a gap.
Yeah, so as long as it's just for decompressing multiple chainable payloads, I think it would be fine.
They are also okay to have their converter driver in the Cobalt, right? Since their Cobalt uses CB memory, UPL currently use hub. Lately, maybe use the combo. But for their convert itself, the shim layer.
Yeah, so the shim is essentially just a core boot payload.
Yeah.
More or less.
Yeah, sure.
Yeah, from Cobalt's perspective, it's just a normal payload. They don't need to understand what the payload would do.
Okay.
Yeah, so Nate, based on our finding, we found that the secondary payload related implementation in Cobalt code base sounds like a work in progress concept.
Yeah, so I mean they have like their menu payload or whatever where it just writes like a boot menu up on the screen, and then you pick a menu and then it goes to, you know, whichever payload it is that you picked. So as long as it, you know, kind of works like that, where, you know, you have multiple payloads chained together, you know, I think it should be fine. You just need to make sure that whatever decompression changes you're making also work if it was just like multiple core boot payloads chained together.
So maybe we can seek for more feedback in Cobalt about the solution 2 or solution 3, right?
Yeah, or we just submit 2 reviews, one for solution 2, one for solution 3, and ask for Cobalt community's opinion.
Yeah. Now I have prepared both solution in my focus report.
Yeah, and I know we have Sheng here who's closer to that community. Maybe if he might have some input also, we could get real time, but to touch the broader core boot community, it makes sense. Yeah, to expose both, and then if people want to know some of the background, we can point folks to this presentation and recording if they weren't able. Since, you know, this isn't the most globally geo-friendly time, but yeah, I think that's probably a good next step. Sheng, do you have any thoughts or perspectives from the core boot side?
Yeah, so far I think this is a good intermediary solution that before corporate actually works together on the universal payload solution. So yeah, I have talked to Tan about this. So I think yeah, you can bring up in the Friday meeting. I think it's a good one. You can bring it in the Friday meeting. We have a Friday meeting for the technical EDK2 discussion with a few people from the corporate community, basically on the EDK2 upstreaming and also for this payload stuff. So I think we can discuss here among a few corporate members as well.
Okay, yeah, if you can share the logistics of that, we're happy to go to the more targeted forum, since this USF one is kind of a clearinghouse for topics of the whole stack. You know, we definitely want to ensure that the more focused working groups or other forums, we can send that conversation there. That sounds like a reasonable next step. And I guess, Gua, what was the pipeline of topics we had queued up behind this one? Do you recall?
For this week, we only have this topic, I think. For the next one, we might talk about the SBL work with UPL payload, and also EDK2 bias with the UPL payload. So that's the two topics, I think.
Gotcha. Did we ever post those prospective topics anywhere with the targeted work weeks, or is it more? I can't recall if we.
I'm not sure we can directly change the website give the topic. If not, maybe I can post it
Something we can
somewhere.
work with Mickey, our community manager, to help.
Okay.
Know, we want to give people a forward-looking, and then if topics want to jump in the middle or something, we want to turn off, we can always do that also. So, okay, that can be some good housekeeping. And I don't believe uploaded the recording in minutes from even last week's meeting, so our last 2 weeks ago meeting, so a little behind on some of this hygiene since we're just getting started. So okay, that makes sense. And Shang, yeah, I know you had some questions on email. Didn't have a chance to ask or discuss on email, so maybe we can use some time here to discuss some of your inquiries. If I know it's 2 a.m. in Germany or something, or 1 a.m. So hopefully you're lucid enough to remember the email, and if you want to have the conversation now, we can always do that.
Oh, yeah, sure. We can discuss about it now.
So I guess the concern was just where are we going with FSP, and are we locking too many things down through interfaces, or I forgot the thread, to be honest. Between Depp and Zowlin's concerns on Twitter versus Slack versus this email, I gotta admit I forgot what was the specific question or discussion. So yeah, if you recall, probably the most salient question you might want to broach here, we can see if we can evolve a discussion here perhaps, because sometimes it's tough to do this on email. It always seems like people are yelling at each other on email, and you can't, there's no inflection on email. So what was I guess the most important of those questions you wanted to maybe get some clarification on or bring a discussion up on? Was it the roadmap, or just what was our thinking in this space? I mean, what was, I guess, your primary concern that we maybe could talk about today?
Yeah, I think generally it's basically designed for this. I think from what I can recall is that they took a look at the GitHub repo. There was a GitHub that talks about the FSP at reset, and that it basically calls the FSP TMNS internally. So the main concern that could be a switching role between the bootloader and the FSP. So currently, bootloader is playing a role to make sure the board is initialized properly, and then it calls into the FSP APIs, and then to do the silicon stuff, and then pass by the control to the bootloader. But seems like from the FSP at reset code, it seems like the role is switching. So what's your thought about this?
I see. So yeah, definitely don't take that GitHub as any like Intel plan of record. We're exploring some potential architecture directions. If you look at FSP, it's really a way to segregate SoC specific code from platform code. It provides some boundaries that can be delivered as binaries, but also you'll notice on that GitHub repo, there's the FSP SDK you can deliver as source. So it's really, if you look at that kind of that one branch as just a model of, are there different ways to decompose the code such that we could have that sort of separation of duty between silicon and platform? And that is, one potential of many. So it was really sort of an architectural exploration more than a plan of record. And then the key there is, how could we do that separation to try to avoid too tight of coupling? And so having this sort of orchestrator, through this new component was one thought on a way to do that. And then parameterizing some additional state through, I think, was it FSPC? Do you remember, Ravi? And Maurice isn't here. Do you remember that component? I can't remember, but there was an FSP component that would encapsulate configuration. We were sort of just using it as sort of a what if concept car on how we could do this decomposition. And again, separation of duty between silicon and platform, and doing it through this SDK concept so that you could even explore different models of openness or non-openness. So yeah, I think of maybe looking at the repo in the vacuum might set off some concerns that this is a committed direction. But really what we wanted to do is sort of explore these interfaces in a way where we didn't have to disclose silicon specific code, and then work with the different bootloaders, the Slim Boot, Core Boot, EDK2, and then luckily for us, this code actually got picked up already by the Orboot community. So they're booting on top of this QEMU based model. So they sort of did the port themselves. And I think that's great. And what works, what doesn't, how could we do things differently? If we wanted to have sort of a referendum on everything open, everything closed, regrettably, that's a business discussion that I don't think is the charter of this forum. This forum really is about, as an engineering forum, as we evolve writing silicon and platform code under these different dialects, EDK2, Core Boot, Slim Boot, potentially Orboot, U-Boot, what might be an amicable model of how we structure the code to reduce the friction of porting between these different bootloaders. And that's even why, I intimated a little bit earlier about our pipeline of topics. We want to have discussions on more shareable library code. We have this first-class shareable citizen called payloads. And if we had the same system board, how might we share more ASL content? Because you can imagine, if it's the same board, why couldn't you have a common board.asl shared among the bootloaders? You really shouldn't imbue or embody a lot of platform code dependencies on something like ASL. We're just not as far along in our development there to have the community discussion, but that's kind of the spirit of why we did it. But I can definitely see why doing more in FSP might set off some sort of business concerns from the the free software movement. I know there's the open source firmware alliance and other communities being set up to try to foster more openness. Love to get that feedback here. And if we were more open, we can't commit we are going to be more open on any layer of the stack because that's a business decision. What might that code look like? There was mentions of silicon SDKs and stuff, I posit that FSP SDK is a class of silicon SDK. May not be the best one. There may be 6 reasons why it's not the best one. And would look at a forum like this just to have that discussion. So that's kind of the spirit of it. And that's why I initially wanted to reply to you on email, but then I thought, there's a famous saying, this French guy, Desargues or something, that said, give me 10 words and I'll hang an honest man. I wouldn't want any of this discussion to be taken out of context. That's why I wanted to sort of give you the long version of why that repo is there or what we're hoping to do and the type of conversation we want to have here. So I'll pause after that 5-minute monologue and maybe see if that kind of helps a little, or do you think we need to do a different way of messaging what we're trying to do here? Probably the best would be to update the document itself to say more of this. Shame on us if it didn't read that way. That's an omission on our part, but that's kind of the intent of what we're trying to do here. And we started with the universal payload because that one has the simplest explanation of code sharing and reuse, right? By design, that's what it is. But our intent is reuse, ease of use, down the stack too. So that's kind of what's happening here.
So what I try to get is that you were saying that the design philosophy is more towards like internally is aligned to the SDK. So it from the diagram we can see that it's more aligned to as a separate IP. So in a way that it can be more how can I put it this way? Structure in a way because it's aligned to different IP, but so there's internally for the source code design, right? If I'm correct.
Right.
Yeah. And yeah, so but also there's also a concern. So how does the future of the FSP, like to put it that way? I'm not sure what's the future.
Yeah, no, I think that's a
be.
good question, and
Yeah.
I'd really like to have more of like the 3.x discussion, but I believe this sort of original design, which actually came out of the FSP working group probably 5 years ago, we have a new wave of people who are engaged in different thinking, and I don't know if we're ready for that community discussion, to be honest. But I think forget FSP 2, 3, 4, 12, forget the number. The idea again is it's this encapsulation of silicon. I think an interesting discussion we could even have in the 2.x context is we've heard a lot of community feedback about FSPS. How some of the core boot community is not even doing some of the callbacks and evolving the code. If you look at what's in FSPS, that could be a potential candidate for more openness. What would that look like? I can't again commit we would open it, but if we were to open something like that, what would it look like? What would it take to satisfy enabling that phase of execution? We would not necessarily say we wouldn't do FSP binaries because there's some ease of use of drop-in, but if some communities wanted to do it raw in their native environment, just as the core boot community elides FSPT for client, what might that look like from a software structure? If it were opened, and this is hypothetical, would an FSP SDK that built FSPS be something useful, or would the community say, don't bother, just publish a doc and we write our own code? It'd be interesting to hear feedback around things like that. Again, we're an engineering group here, not the product folks. We're purposely, set up where the document isn't on intel.com and those repos are just sort of meant for having this community discussion. That's the kind of feedback we'd hope for. But if it's the thing I worried about with Zowlin was this dogmatism of Intel's doing too much, copy CEO of a company. I mean, that's not a discussion. That's yelling. And engineers, we can't do much just listening to someone yell at us. So I think the message would like you to carry back and maybe give us some counsel, even if if this is the right mechanism to do it, is have that conversation of if we were to have something like an SDK, what might it look like? Could we, start the reuse at the payload and work our way down through platform? And if it made sense to do some silicon, what might that sharing look like? But yeah, don't take the FSPR and the 3.0 as a statement of our company's intent, because I can't represent that even. I'm not the manager, business guy anyway, right? But I can talk to you guys about for where we are sharing or could share, what might a model look like. So for example, if we wanted to have shareable code, should it just be permissively licensed in the third-party directory of coreboot.org? Or should we dual license? And is there a way that you take code directly, or you would like to see it that way? That's the kind of maybe feedback. Or if there's another community or vendor doing it in a certain way you think is very scalable, and there's some design pattern you'd like to let us know, take that feedback. That's kind of what we're hoping for. And you'll notice even in the specification, although we didn't fill it all the way in, it's not, just Intel x86 like on the payload. We talk about RISC-V and ARM. We might not have prototyped everything, but we want to have lack of friction in some of these higher layers of the firmware. So definitely interested in that conversation too. And I know
Yep,
Ray and others we've been chatting. Correct me if I'm wrong, but yeah, this is kind of how we've been vibing. And I asked that we just take these discussions external because we don't write BIOSes for everyone's board, right? So it's kind of what we're thinking.
Yeah.
If I may chime in here, Vincent, I love everything you said. 100% agree with you. And thank you so much, Shank, for listening, I guess, and help us guide us through this. I would just want to, it's a complex conversation and it has different swim lane, but I think you need to put it in a balance and context. So, I mean, this is Fadi speaking, my personal, objective is to, there is a key objective. Let's define the objective. Everything has become tactic and strategy. The spirit is there. The spirit is we want to be open as much as possible, as much as the business allow us as engineers, but the engineers need to solve a problem. And one of the problem is not, to me, is not the openness. The problem is ease of use, is scale, is supporting diverse market requirement. So how can we become, easier to, implement firmware at a large scale? So some of the SDK concept, I mean, even though sometimes that can be closed, but that can serve the ease of use and scalability requirement. So I don't think gonna be one or the other. So we need to, whenever we propose, as engineers propose solution, to go to our, business managers to make decisions, we need to try to solve all requirements, not only openness for the sake of openness, but more how can we easily scale, how can we easily deploy firmware very quickly. So that we need to keep that in mind, if it makes sense.
Yeah, thanks for Vincent for your honest feedback, and also Suhairi as well. So I can't represent the corporate committee, but my personal opinion, I don't think it is quite practical to open source the whole FSP, because there's always some space that we need to protect, and we need to respect that part, that some code has to be in that way. So this one I need to be sensitive to that. But I think a more pragmatic solution is that to maintain a more delicate balance between the openness and also the flexibility and stuff. So like what Vincent also mentioned just now, I think the best way is also to have a engaging the conversation to understand what the need of both sides, and also to at least currently to publish more documentation so that people can have a good way to kickstart the conversation and understand where the right way to heading on. And I think basically the main fear, especially in this context of the FSP, whatever the next generation of FSP is, that the fear is that the delicate balance between the openness and the closed FSP is broken, because when you put more and more stuff into the FSP, then there's much less space in the open source or in the bootloader like Slim Boot or Coreboot can be done. So I think the best way is to maintain the balance and then to see that in the context of the engineering, So what can we innovate in the context of really go for more openness? Can we actually make our boot solution to be more faster and better and can be more compatible with all the other architecture like the RISC-V and everything else? I think this is a direction, and it's not an easy process, but it's a good start to engage the conversation and also to have some documentation published. Yeah, that's my thought.
So just to kind of read in on what you said a little bit, Shang. Yes, I understand the desire for more openness. Here in this forum, we can't really comment on that. That's more of a business decision, as Vincent mentioned. But what I can say is that I don't think, if you read some of Philip Debonwise's tweets, he's thinking that we are trying to turn Coreboot into basically a YAML parser and generator. And I don't think that's what anybody here is thinking that we're trying to do. Just to put that out there.
Yeah, no, I think don't take and take some of it as omissions and maybe the document flow and a review out of context may have gotten that weird impression at exactly, Nate. I think that the real things to me that matter are, like when I was at OSFC and I mentioned, hey, the MP PPI is optional, and they said, oh no, the latest, Gen 9 and onward core code, it's required, meaning we have some artificial coupling maybe between a binary and platform code that slows everyone down, right? Think problems like that, I think we as engineering community want to look at, because we don't want firmware enabling to get in the way. And we understand why sometimes open helps for debug, security assurance, but sometimes folks want the binaries for drop-in ease of use so they can be complementary. So yeah, we just want to suss out those things. But yeah, our goal was not to sort of, kneecap Coreboot and demote it to, yeah, as you said, Nate, a YAML parser. And yeah, and it's unfortunate, yeah, that Philip, his only impression maybe was reading some of that and maybe missing the December talk where we got a pretty good flow among all the community around this. But it's good to know he got his thoughts out there, right? Because hopefully we can start closing the loop. The only concern I had was closing the loop on Twitter with, at a bunch of executives. It's hard just to have a free-flowing engineering discussion. So if this isn't the right venue, if you think there's a different one or a different way to have the conversation, we're happy to support it. But yeah, you weren't like ignoring the tweets and the Slack. It's hard to have a nuanced discussion on some of those medium, and even email's tough because it always seems like people are yelling, right? Maybe you had a certain context in mind when you type something, but someone takes it out of context. And so that's why I'm glad we could have the conversation today, is at least you can be the initial emissary on the message. And again, live discussion in my preference is a little better than email. Email is better once we have some proposals and some GitHub hashes where we can compare notes and specific opens in a document. But in those early phases where intent is involved, it's hard to exchange that on email. So yeah, we weren't, again, my apologies, we weren't purposely ignoring your inquiry. I was going to reply to your first one, but then I couldn't think of a answer that would keep like Patrick Gorgies of the world to start yelling more, right? It's like, so we want to explain real time first, and then now you know where our headspace is, have a discussion in that sort of cognitive box, right? So as Nate said, we're not trying to take over or turn you into a YAML parser. We're just trying to make things easier for firmware development across all communities. And because again, this should not be an area where you have difficulty or complexity, because it just gets in the way of, shipping and delighting end customers. And so, I always say, people used to say firmware's value add, and I'd say, no, it's value neutral if you're doing well, and then it's value negative when you screw up. Is it slow, hard to use, has a lot of bugs or CVEs, and need to get it back to neutral, value neutral. And then maybe then when it's value neutral, there's invention and value add on top later. But I'd argue a lot of our community work where there's a lot of friction that maybe we can help remove by working together. And that's what we're hoping to do in this forum here. So yeah, I think since we have our brave community manager Mickey back, one of the things I'd like to do is get our prospective next topics out there. Maybe we can do some agenda bashing. If people want to change it, probably maybe market this meeting a little more. At least let folks know what's happening, since now this is probably our third meeting, and I think we have some momentum and structure forming around it. And and there's no bad questions, because if this is a concern, by not asking the question doesn't make the concern go away. So saying thanks for being candid about the concern and also your opinion on top, because I think that definitely helps. We'll just we're not dogmatists, or it's not a religion, right? This is a just trying to again reduce the cost. I spent 15 years trying to tell everyone to do EFI, and I don't know if that's the most positive way to embrace people. I think what you do is appreciate the diversity of the firmware ecosystems, and where we see maybe duplication or work that's not differentiating, what the Amazon guys call the undifferentiated heavy lifting, i.e. porting system board A's ACPI code over 6 times, or having to debug a weird interface hidden behind a blob. Those are good problems to work on together, in my opinion, because those complexities and friction don't add business value, but they definitely add cost and complexity sometimes yields bugs and security issues, and that's not good for anyone. So, in my opinion. Cool. Sounds like we got hit the 80% on this one. Any other opens or topics we want to hit on meeting number 3? If not, I think we maybe can role model good meeting hygiene. We had an agenda, delivered our topic, we had opens on the community list, we serviced that, and then sounds like no more additional opens to chat about today. So anyone disagree with maybe we call it for today?
Second that. Thanks so much. Thanks, everyone.
All right, cool. Okay.
Thank you.
All right.
Yeah, bye.
Thank you. Bye-bye.
Thank you. Bye-bye.